Hi folks, today we're going to walk through the design of a sip and puff enclosure that I made making for Jim Lubin. We're going to go through Fusion and a couple other things and show you how we made it. So the first thing I want to show is the sip and puff device. So this is the sip and puff device that we made for Jim Lubin. So it's got a sip and puff, it's got this is actually a saliva ejector for a dentist. And that's what you use to control this. And then it goes into the sensor, which I'll show you in a minute, that goes into a Bluetooth chip from Adafruit. And what I really want to talk about here isn't the software to do Morse code, and it's not really about sip and puff. It's more about this this enclosure and some of the techniques I used on this enclosure that I really think are going to be handy long term. So let's take a quick look. All right, so here's the device. Let me kind of zoom in a little bit so you can get a good look at it. I might turn off my own camera here in a second. All right, so yeah, why not? So here's the actual enclosure, and let me kind of show you how this thing works. So this has got a blue 2.5 millimeter hose, which is the correct size to go onto the Adafruit MPRLS ported sensor right there. And there's some problems with using this kind of a sensor. This is going to feel the sip and puff suction or pressure, and it's going to transmit that as a signal into the microcontroller board down here. But it's got a few problems. If you have a hose on it and you tip it, you can snap this port right off of the sensor, which makes it useless. In addition, you really want a way to separate the connection to the board from the connection to the end user. So you want to be able to swap out this hose, right, and put in a different user, replace it when it gets saliva in it. I mean, generally speaking, you need to be able to disconnect this. So I went through a number of different approaches for that. I looked at using a cable gland like this. This wouldn't solve the disconnection problem, but let me darken that a little bit here. There you go. It wouldn't solve the disconnection problem, but at least it would give the strain relief and keep this from breaking the board. I also looked at making these kinds of connections, and I did get to the point where we could print this. Interestingly, really the only way to print these is to print with this side up, which kind of makes this difficult. If you try to print it oriented with this down, it doesn't work. And even when you do get this to print correctly, which we did, it dramatically reduces the airflow, right? It really shrinks how much air can get through this. If you wanted to have this kind of a nozzle approach to connecting. So we tried this, it didn't work. Technically it worked, but it wasn't going to work long term. So we actually went online. I went online and I found these. Okay, so these are about $1.50 if you buy, or $1.50 a piece if you buy 10 of them. So they're $15 for 10. And what they do is they connect on the outside of the hose instead of on the inside. So these are quick release connectors. That's in there. It's not coming out. If I press this, it will then release very easily. This is kind of exactly what we wanted, right? We want to be able to push this in. If we want to connect it to another one, we can push one in over here. And now these are connected physically, and they also will pass the air through, and they're easy to disconnect. So these are kind of exactly what we wanted, but there's not really an easy way to screw these into a wall or things like that. And so that's what I kind of want to get about this case. So what this case did that's different, and I'll try to show it clearly here. All right, so what this case does that's different is if you look carefully right here, it actually has, let me zoom in. it actually has a little indentation that will hold this thing in place. It is exactly shaped as necessary to hold this in place, and if you watch, this will actually click in just like that. And so now we've got the board over here in the slot for it, and this is now secure, and it's not going to come undone like this. It's in good shape. I can actually loosen this a little bit if I want to, so that it's perfectly vertical, and we're pretty good. Okay, it is kind of tricky to get this length of hose correct, but that's just trial and error, right? So we can adjust that. So this is what I want to show you. I want to show you how to make this kind of a box. I just think that there's going to be a lot of times when we want to have a wire or something that is snapped into place and that won't come loose, but it's entirely 3D printed. There's no screws holding it in place or anything like that. And I think it's just a technique that's worth sharing. As far as the top of this goes, there's a lid that I make, like a lot of our lids have these little press fit or snap fit cases. And in this case, I put a little tab over here so that when you snap it on, it even closes up the little gap here. Not necessary, it just looks good. And so that's the top. I did make it translucent so that you can see the status light from inside the light. And you see as I sip or puff, well, you probably couldn't see me do that. Doesn't matter. The red and blue are when I sip and puff, and that means it's recognizing it and it's sending appropriate keystrokes based on Morse code. So what I want to do is not just to show you that idea, but to show you how to do that. So before I go on, let me make sure I don't have any questions. I don't have any questions. And let's see. I don't think. If there are any, I'll check on the main feed as well if there are any questions. But I'm just going to roll through this. So let me show you how to do this in Fusion. Okay. So we're going to go into Fusion 360 right here. And this is actually the part that we're talking about. I'd like to walk you through how I made it in a very high level, but to kind of be complete and show you kind of how it works. So let's turn this off. So one of the nice things about Fusion 360 is you can actually go back in time and walk forward with all of your steps. Okay. So let me start at the very beginning. I'll rewind this to the very beginning. So the very first thing that I did as I started this was I inserted into my project this coupler right here. Now you might say, where did I get that? I made it. It was actually really easy to make. I went over here. So this is the tube coupler that I made. You can't just find this one online anywhere, but it's not that hard to make. So we'll start with this. The very first thing that I did was I actually took a picture of myself holding this coupler, and then I made a sketch that drew, if you look right here, on top of it. So I created the profile that matched that device. I didn't just ballpark it. If you look, it's got the actual measurements for the width of this and the height of this, and the angles are correct because I drew on top of it. Once I had that, I did what's called a revolution. That creates a 3D shape that by revolving it around an axis. And everything else was I put a hole through it. So if you look right here, there's actually now a hole through this. And then I just rounded the corners and changed the colors. So this was an easy part to make. It's kind of neat when you look at it on top of the picture. So it kind of looks like I made this thing be 3D, which is kind of cool, right? So once this part exists, I can now form a box that will work with it perfectly. So here I've got that part. I've added it into the box project here, and the next step is to add the other things that I want to put in the box. So the next thing I want to add is a feather. This is a feather Bluetooth NRF 52840, and this entire 3D model is available from Adafruit. You can just download it. I didn't spend any time at all making this. I literally dragged it into my design and the entire thing is already in here. So I just used it, okay? The next thing I did was to add another part, which was the pressure sensor. Adafruit was good enough to put that in here as well. And I did a lot of work here where I kind of laid it out different ways to try and figure out where do I want these things to be relative to each other. Do I want it vertical where they're stacked on top? Do I want it horizontal? I decided I wanted it to look something like this, where it's longer and skinnier. And so you'll see that this is laid out in exactly the way it is on the board. There's the board. There's the vertical pressure sensor. Here is the coupler. So I laid it out like this, and now the next thing really was to create just a basic box, right? So I move things around a little bit in here because it's going to show you every step I made. And actually, the very next thing I did, I forgot I did this. I actually created a hose, right? So I went ahead and created a hose to make sure I could see what it was going to look like as we went. And that's just a matter of drawing a line and having doing a sweep along that line. The next thing I did was to finally create the box for the bottom. Okay, so here I just created a rectangular prism, a box that fit around the parts that I wanted. I then did a shell, which basically means I made it hollow. Okay. And I added, if you look right here, let me back that up for a second, you'll see that what I want to do right here is I want to make this thing exactly fit the coupler that I'm putting in here. So I need to make this wider, so I do that. And then I want to subtract. So if you look right now at this box, if I hide the hose and I hide the coupler, you'll see it's just a box, right? There's no hole in it or anything like that. So the next thing I did actually was I actually subtracted, I used the combine tool to subtract the box, the coupler from the box. So you'll see now it has subtracted that. I need to hide that inner piece right there. So now I've got a hole that will be exactly the same shape as the coupler. You might think, oh, you're going to need a little bit of spacing. In our case, we won't, okay? Because the coupler has some give to it. It's actually a plastic that's not perfectly hard. The next thing we did here was we actually went in, let me make sure I can see my sketches. Right. So the next thing we did was to put, let me show you this. I projected this shape up on the top. So I created a sketch here and I projected the edges of this up on top. And I added some lines to close that so that I could then subtract it. So the next thing is I cut this down. So I extruded down and cut down to where this hole is. And I intentionally, if you look carefully, I intentionally didn't cut all the way to the middle. I intentionally left these points here. I intentionally left this so that it has more than 50% of the circle remaining. And that's intentionally to hold it in place. So when the coupler goes in there, right, I want this to be grabbing it and holding it down. So this won't fit. If I did this right now, it wouldn't actually go in because these are too pointy. So the next step was really just to start rounding corners. Okay. So I rounded some corners to make it smoother and a little bit easier for that to pop into place. Really, the remaining things are normal kind of case things. So I'll zoom out here for a second and kind of walk you through stuff. But all of the rest are things that you'll see in Noah and Pedro's guides as well. So I rounded the corners by adding fillets. I cut a hole for the USB port over here. I added the standoffs for the board to hold it off the bottom, and really did a lot of rounding of corners and smoothing and adding of fillets to add some strength in here. This is going to hold that vertical board right here. And then I know I'm getting close to being done when you see me add the tabs that hold the top in place. So everything you're seeing here is just rounding and stuff. So Here is the top. So the next thing I had to do is to make a top that fit it. And we can go into some detail on that, but it's basically a pretty standard snap fit top. And I'll just skip forward a little bit. The one thing I did do that I don't usually do is I added this little notch that comes down here. So I won't go into the top as much. If you ever want to talk about snap fit tops, so we can do that. The thing that holds them in place are these little tabs right here. And I'll tell you that Noah and Pedro did a fantastic job of designing these, and I use them in all of my cases now. So these little tabs are just enough to hold it in place and let it pop off easily. Okay, so that's really kind of what we needed to do. You'll see that this now, when the coupler snaps in there, if you look down, you'll see it's kind of grabbing it, but it's not going to be so hard that it's going to be hard to get it in there. The only other thing that's probably worth showing you guys on this is that I made an animation. A lot of people have seen the animation and say, "Hey, how'd you make the animation?" The animation is actually pretty straightforward. Fusion 360 has an animation tool built in, and so I'll turn on all my parts here, the hose and the top and everything else. And if you go into the animation tool, it will actually, whoops. So if you go into the animation tool, there you go. And let's go all the way back to the start. It will actually let you make an animation that looks like this. So I'll play it first. It looks like this. So you see the hose going on the thing and getting snapped into place, and then you put in the feather, and then you put on the top. And that's a really cool animation, and it really shows how to do an assembly, and it really isn't that hard to do. I can give more details another time, but basically the only real trick on this is to turn off view recording, and then at any point in time, you can tell it where you want the parts to be. So if I wanted to add some more at the end of this, I could go out another 11 seconds and say at that point I want to move the top up and maybe rotate it. Okay, so we'll rotate it around like this and this so that you can see the words, and I don't know, move it back that way. Okay, so I want it about there. So I can say, okay, at that point, out a couple seconds, I want it there. I'll say okay. And now if I replay this, you'll see it's going to do all the same movements that I saw before, right? It's going to move this in, it's going to snap that down, and then it's going to pick it up and move it where I want it. Now, obviously, I don't want it to break through the thing, but that's just an example. So that's fine. So at this point, if we want, we can actually move it up a little higher so that it doesn't hit the thing. There we go. Okay. And so now let's turn the view back on and go all the way back to the beginning and watch the animation. So we'll see it getting plugged in, snapped in, the feather put in, put the case on, and then take it off again. All right. So this is a tool that's built into Fusion. It's very powerful for animating what you want to do. And I do recommend that you guys play with it if you have any desire to make 3D printed stuff. Okay. So back to the design view of this, so you can see this. I think that's kind of what I wanted to go over when it comes to the snap, the Sip and Puff box. As far as the actual device goes, there's one other thing to kind of make really clear. The way this works is that this board senses sips and puffs. There's Python code that runs on this microcontroller that then translates these into USB keyboard commands, USB keystrokes. The reason we're using a Bluetooth board here is we would also like this to be able to send keystrokes to your iOS or Android devices. That would also make this a Sip and Puff switch for switch control for iOS and Android, which would be kind of powerful and cool. Total cost on this is, I think, about $10 for the Sip and Puff sensor and about $30 for this controller. Let's say $40 with the wires and case. That's about $1. Let's say it's a $40 to $50 project. It requires no power. It requires no battery backups or anything else. Everything's just plugged into USB. And it doesn't require any other devices. So If this is just powered from a battery, this will run and send Bluetooth when we get the Bluetooth working. Bluetooth is not working yet, but it is very high on the priority, and it's why we're using a Bluetooth chip in this in general. Thanks for watching this, and I hope you enjoyed it. If you want to see more of these Fusion things, let me know. If you have any questions, just reach out to bill@atmakers.org or join us on the Facebook group, whatever works for you. Bye.